Cisco Secure Firewall Demo, NetOps Use Cases. Now, this session is going to focus on some common use cases of the network operator, but also include differentiating capabilities that only Cisco Secure Firewall provides. All right, 7.4 introduces Zero Trust Access. So this allows users to access private applications without requiring additional software on their devices. So no need for VPN for these use cases. Now, this functionality leverages SAML-based authentication and supports Duo, or MFA platform, that's risk-based in all other major identity providers. Encrypted visibility engine enhancements. So this is a differentiator with Cisco, the ability to understand encrypted traffic without having to decrypt it. Now in 7.4, we introduced the ability to block traffic based on the disposition found by encrypted visibility engine. In 7.4, we also enhance SD-WAN capabilities. So we start adding things like summary dashboard with high-level overview of WAN devices and their interfaces. It helps identify issues with the underlay and overlay VPN technologies, troubleshooting issues with drilling down to existing health monitor, device listing, and site-to-site VPN monitoring, and then monitor application performance and metrics of WAN interfaces. Threat defense also steers application traffic towards these metrics. Azure AD user identity. So now it's possible to leverage Microsoft's Azure AD as an identity source alongside with Cisco Identity Services Engine for visibility and control. High availability support for remote branch deployment. So again, just optimizing the ability to make sure that we simplify the branch deployment mechanisms and provide high availability when we do so. Cisco Secure Dynamic Attribute Connector in Firewall Management Center, so built in. Now, this dynamic attribute connector allows us to pull in attributes that are dynamic, like Microsoft 365, GitHub, and many others. But the beautiful thing here is not only do we pull in these attributes from these different sources, we're able to translate that to that dynamic IP that they tend to receive and automatically have them deployed to policy that's already been delivered. So if an IP changes in Microsoft 365, you do not have to push policy to the device itself in order for that policy to take effect. It's already there, that IP gets updated, and you're good to go. Just like if an IP is removed, it's also removed from policy. This tends to be another differentiator for Cisco. Now, there's additional resources. We'll make sure that these are available, but the first time that you log in, you're going to see this with 7.4. Bookmark them. They're great resources. All right, let's get started. Let's do the demo. First thing, let's move into dusk mode. I like dusk mode, but choose your preference. Now, remember, this persona is focused on NetOps. We're going to drive outcomes as we move along that would be typical of a network operator. It doesn't mean that they're not focused on some of the advanced security capabilities, but we're breaking this up based on network operation capabilities, based on a couple of use cases, and we'll do separate demo with security operations. All right, let's go to object management. Now, you can see there's a ton of things. The goal here with object management is to create an object once and be able to leverage it anywhere in any of the policies that obviously can align to that particular object. Now, like anything, come in, add an object. We'll add one here because this is something a network operator is going to do from time to time. And we'll create this as an FQDN. And now it will be available in things like NAT. Now we can search for objects in here very quickly and find them. So if we have hundreds or thousands of objects, it's very easily to search for them. And we can show unused objects. So objects that are not in use. And you can see the one that I just made is currently not in use. All right, application filters. Now, although application identity-based firewall is something that's fairly common, the differentiator here is that we've got two capabilities of identifying applications within Cisco Secure Firewall. One is encrypted visibility engine. We'll talk more about that as we move along in the demo. And Open App ID, a community-based language that anybody can create signatures. You can do that within the platform. You don't need a ticket for this. And then what you can do is create an application filter and put all your specific custom applications, the ones that we create, the community creates, and build application filters for policy. Now, external attributes. These are dynamic objects As I mentioned earlier in 7.4, we pull these objects in from GitHub. You can see there's WebEx here, and I can see all the IPs. These are dynamic IPs that may change frequently. And it's very hard to build a policy with WebEx destination if the IP continues to change. Now we can add additional dynamic objects here as well. The goal here is once these are deployed, as the IP is changing and we're getting these updates, it's automatically pushed to policy. You don't have to manage this. This is key. Now let's create a new policy as if we're going to deploy a branch office. And again, we can look at some of the default actions: block, intrusion, network discovery. We're going to be a block action. We're going to run this as a next generation firewall policy. We'll go ahead and hit save. We'll go ahead and add our device to the policy and we'll hit save. So let's go ahead and edit that policy. This is the new interface for access control policy. And you can see all of the rules, packets, pre-filter, decryption, security intelligence, identity, access policy, and more. And we'll get to that, are at the top. Very easy to pick from or jump to the specific areas of focus. Now first thing we want to do, branch office, they're going to go direct to internet. We want to make sure that we're adding the security intelligence feeds and categories to the network block list. So anything that matches something from a network to a CNC server or a URL that's suspicious or a Tor node, we're going to add that to the block list automatically. And we're already increasing our overall security effectiveness. Now, the beautiful thing here is we can integrate this with Umbrella and have consistent DNS-based policy across all the ways that we can deliver that control. We also get the ability to leverage built-in DNS policy into the platform. So we can do things like DNS sinkholing. Let's go ahead and save, and we'll go to more advanced settings. And here there's a bunch of things. We're not going to go through everything, but we'll talk about threat detection. There's some port scanning capabilities. Elephant flows, these are flows that tend to be large, and typically you want to exclude them from advanced inspection. So this is just the ability to allow the platform to help you determine what elephant flows might exist and address them as needed. The other one is TLS server identity discovery. Now this allows us to drop from TLS 1.3 to 1.2 to check out things like the server name information and have the ability to create what we call as a side channel to determine whether or not there's risk to the destination without having to decrypt that policy. The other is encrypted visibility engine. Now, this allows us to look at encrypted flows without having to decrypt them and have high levels of efficacy in regards to whether or not these flows are nefarious or not, and also have the ability to mitigate against suspect or nefarious flows. There's no real performance penalty here either. And we've got some thresholds that we can adjust, but we'll go ahead and block traffic. We'll, based on the encrypted visibility engine score, we'll use the default setting here and we'll hit OK and save. And we've just optimized. This is a big differentiator. We just offloaded having the need to decrypt everything through TLS proxy because we've got two optimized capabilities to be able to determine risks sooner. All right, we went to analysis, unified events, and check this out. We see encrypted visibility indicator of compromise. Now, very quickly from unified events, we get to see everything. We can look over to the right here and pivot. We can see the reason, the protocol. We can scroll down that we can see its web browsing, URL category, that we can see the URL itself. We can see the reference host. We can see an IOC was triggered. Tons of attributes. We get to see the encrypted visibility fingerprint, the process name, the process confidence score. We get to see the encrypted visibility threat confidence, the encrypted visibility threat confidence score. All right, let's close that out. Now, the other thing we can do is we can actually set in unified events all kinds of different attributes. Again, this is just to provide additional visibility. Now, I want maybe visibility into some of these encrypted visibility capabilities. And so I can very quickly come and turn them on, hit apply. And now all of a sudden, now the events are coming in. And now I have that column with the information specific to encrypted visibility. So let's check that out. We'll scroll over to the right. And here we go. There's the fingerprint. We see the confidence score, process name, all the stuff that we saw before when we were looking at the event. But we also get to go in and look at view encrypted visibility engine process analysis. So now we can go in, we see the customer name, email, the version, the server name, the IP address, the fingerprint, and the process name itself, prevalent, server name, and you can provide feedback about any processes from the list below. So just select the applicable entry and submit your request. So again, there's a feedback loop that's provided within the platform. All right, let's get out of here. All right, we took a little side channel just to show you the encrypted visibility piece once we enabled it. Let's get back to that policy and let's build out a rule. Now, identity, we can also add identity at any point in time. Now, I'm just showing you that there is one that's already been configured called passive authentication with Active Directory, and now I can apply that. And now I have user identity as part of this access control policy. And now I can use them in any of the rules that I build. So let's go ahead and give this a name. Block bad geo. Now here we've got all kinds of options: block with reset, interactive block with reset. So an interactive block would give you a page. Logging, we're going to log at beginning because we can't log at end because we're blocking the connection. We'll confirm that. We can set a time range if we want, and we want to make sure that the rule is enabled. Now, everything can be done here. Even if you don't have objects created, you don't need to go somewhere else to create the object. You can build this within the rule itself if you don't have the object already defined. Now here I could look and drill down into each country or continent itself, right? I can block all of Asia if I wanted to, and it gives you a description of all the different countries that make up Asia. But in this case, maybe I am going to pick on a couple of countries, and maybe we'll say we're going to block China because we just don't do any business with China, North Korea, Russia, maybe another couple that we can add here as well. Again, just because we don't do business with any of these countries. So we'll go ahead and add them to the destination list. And now we have inside to outside going to these geos. We're going to block them. We could do it based on ports, applications. We can look for specific applications. So you can look for an application itself with the words Tor in it. Maybe you want to be a little bit more specific and look for torrent. We can do it based on user too. So we could do it based on Active Directory. We could do it based on user or group. And if you have any special identities, like guest as an example with the platform itself, you can certainly use those as well. We can do it based on URL, and we can even do security intelligence at a rule-based levels with URLs as well. You can do it based on device type. You can do it based on security group tag. So you can see that here, building IoT. You can do it based on dynamic objects, as we mentioned earlier, like WebEx or GitHub. And remember, when you're using dynamic objects, you don't have to push policy. We can do it based on location IP. All right, let's go VLAN tags just to round this out. It's not deployed in that scenario, so in this case, we're not going to use VLAN tags. We can go ahead and enter a comment here on the policy. So blocking geos, we do not do business with, that aligns with our current security policy XYZZZ, whatever it might be. Close that out, hit apply. And now we have our first rule. And the default action here is deny as well, because we deployed this as a firewall as opposed to intrusion prevention system. And so you can see lots of different, I can clone the rule, I can copy the rule, again, making it a little bit easier to navigate or replicate things that you've already put some time and effort into. We can enable rule conflicts, show rule conflicts, warnings, or policy warnings themselves to give you insight if you have any duplication or rules that doesn't make a lot of sense based on where they are in the hierarchy. We'll go ahead and add another rule. We'll block bad URL. And so we've got two block policies right out of the gate, inside to outside. The network itself is going to be the inside network. But the beautiful thing here, again, as I mentioned, you don't have to go anywhere. If you had another inside network that you wanted to highlight here, you can certainly do that. Create that object. And now that object's available for you to use. So let's assume that's the case here. We're going to use inside 2 that we just created. We can do port-based. Maybe this is HTTP only that we're concerned about for whatever reason. You can do it based on browser, or you can search Edge. Maybe you have a specific browser that's only authorized in the organization, or there's a browser that has a vulnerability, and so you want to maybe leverage that browser as one of the conditions. You can also use user identity. Now you can do it based on URL. That's what we're trying to achieve here. So let's go ahead and create our detectedbad.com. Again, there's other ways of doing this. This is just showing you that you can come in and very quickly add objects within a rule very easily and build out the scenario. And the goal here is not to add as many attributes as possible. The goal here is to add just enough attributes to make the flow match and nothing more. Now we'll have a final allow rule here. We'll turn on logging. It's inside to outside. We'll log at end of connection. The rule is enabled. We'll go ahead inside to outside. Again, networks, if we need to modify anything, maybe we'll just grab the inside network itself, which encompasses a /16. So that's all we need here. Ports again, applications. And look, if we go web browser, we can say, you know what? The only thing allowed in the organization is a specific web browser, and that's Chrome. Right? It could be Edge, it could be whatever, right? The point here is that if I use the browser itself as a condition, I significantly reduce my attack surface because all other browsers will fail. They'll never match this condition, and therefore they'll default to the block all policy. Now, maybe what I want to do is do this for all domain users. So inside to outside, inside network, all domain users using the application Chrome are going to be allowed here. Now, they're not only going to be allowed, but we're also going to attach maybe the intrusion policy that was created by the security team. Now, variable sets talks about specific attributes within the organization so we can define them so we get an understanding of context. And then file policy, we're going to attach this just to catch malware as an example. Again, that might have been created by the SecOps team. Now we have our policy. We see intrusion. The variable set is set. And you have the malware block policy inside to outside, the inside network only using the application Chrome. Done. We have a completed policy for at least access control, and we can send this over to our devices. Now, before we do that, we're going to go ahead and create a health policy. The health policy is only going to check the health of the device. And so we can come in here and use the defaults. We could adjust this, but you can see application hardware, CPU thresholds, data plane statistics, deployment. And you could come in here and adjust these as needed, right? Disk, high availability, integration with SSE. So we have the ability to build the integration and streamline that process, and we monitor it as well. Memory, process, SD-WAN, again, snort, threat data updates, and so on. There's tons of stuff in here. Now you can just hit select all and turn them on. There's a couple of advanced settings that you could do here, save it out, and then you can attach it to the specific device that you want it deployed to, and you're done. Right? You have a consistent health policy delivered to all your branch devices, regardless of where they sit. Now, this might be consistent for all devices, but again, you have the flexibility and freedom to be able to create the health policy that's specific for the use case that you're driving towards. Now, platform policy is a little bit different, where we could come in and create a platform policy that does things like, do we want ARP inspection? Banner? Yes, we do. This is owned and operated by. DNS resolution settings, external authentication, HTTP access. You've got SSH. All of these are going to be available to you, where you can come in and create this once, and again, deliver it on one or many of the devices for which this policy should apply for. You're not having to recreate this every single time. So maybe for SSH, we want to use RFC 1918. Obviously, we'd be more specific than that, but you get the idea. Now I've just enabled SSH access, at least from an internal IP only. Time synchronization and others. So we'll go ahead and save this. And now we've already created an access control policy. We've created a health policy and a platform-based policy. Let's configure NAT. We're coming from the branch, so let's go ahead and configure NAT. We'll give it a name, branch NAT policy. We'll add the device. We'll hit save. We can do NAT exemptions here as well. And what we're going to do is we're going to create an inside to outside. We'll make it dynamic. Translation. We'll go inside network. And we'll just translate that to the destination interface IP. And that'll be the outside zone. And we'll go ahead and save that. And now we have a basic NAT policy for users having the ability to go outbound. Remember, when they're accessing the internet, that policy is dictating on what they have access to, which is limited to the Chrome browser itself. Now here we're going to go to device management, and let's go ahead and jump into the device itself. First thing is we have the ability to jump into interfaces and configure the interfaces as needed, as well as virtual tunnels. Let's go to device, and this is a summary of the device. So you can look at logs, CLI, licensing, management, the health of it, the inspection engine. Inline sets are available, as well as DHCP and VTEP. But let's go to routing. Now we have VRF capabilities. So if you have duplicated IP addressing schemes, or you want another way of containing a layer 3 network, you can certainly do that. And we have policy-based routing, SD-WAN capabilities. So here we have an ingress interface that has 3 match criteria and forward actions. So we've got one that's direct to internet for collaboration. It's going to send through minimum jitter interface on the outside. You also have Google applications. It's using the outside, but it's looking for minimum packet loss. And then you have one that's YouTube. And again, it's looking for jitter interface, and it's using outside. And you can load balance across multiple interfaces as well. And you can fail over or have a backup. Lots of different ways of optimizing your applications and services with Cisco Secure Firewall. So let's go ahead and look at one of these access lists. So we just jump to objects real quick, go to extended, PBR, direct to internet. If we go ahead and look at this, you'll see here, allow any source, destination, applications are WebEx, any, and that's it. So that's what defines the actual application policy. And then we tie interfaces to that. Now, let's go back to the device management and let's talk about troubleshooting. So we've got packet tracer, capture, revert upgrade, health monitor, and troubleshoot files. So we can do that all from the interface itself, but packet tracer is a differentiator. If you want to truly troubleshoot the firewall very quickly, you can jump in here and do packet tracer. You give it IP, protocol, pick the device, source port. You can then pick the outside interface, pick the destination port, and you can pick additional attributes as outlined in the interface. In this case, go ahead and hit trace, and it's going to simulate this policy and run it against your platform's rule set and tell you whether or not it's passing or failing and where. So I can see the trace results drop. That's the summary. And as I scroll down, why did it drop? Well, it was dropped based on the snort, and the firewall blocked or blacklisted the preprocessor, blah, blah, blah. So it gives me insight exactly into what's happening. So if a user calls you and says, hey, something's not working, you can very quickly come up and simulate the source, destination, and determine an outcome here. So it's pretty neat. We can also jump and do quick troubleshooting within the GUI itself. Again, you can drop down an SSH into the platform and do the same thing. But if you're here, you can very quickly say, I just want to see the routing on that particular device. And certainly you can see that very, very quickly here. Remote access VPN. Now, what I want to show you here is how simple it is to get remote access VPN. If you want to use traditional VPN capabilities, we have a wizard that all you have to do is walk through policy assignment, fill in the details. It walks you through connection profile, secure client, so select the version, access and certificate, and then summary, and hit apply. And you have remote access VPN set up and ready to go. So what most people are excited about is transitioning to a zero trust framework. And Secure Firewall introduces zero trust application, the ability to provide zero trust outcomes leveraging Cisco Secure Firewall. Now let's go ahead and look at a policy here. So there's a couple of options here. One is create an application group, and it allows us to group multiple applications, share common settings such as SAML authentication, security zone, and security control settings. We can also add an independent private application with SAML authentication, security zone, and security control settings. So if we have like-minded group, we're certainly going to leverage that. If it's an independent application, we'll just go ahead and select add application. So go ahead and add application. Here we give it an application name, and then you'll define the external URL, the application FQDN or network IP. So here we'll use the external URL as the application URL. You'll have an application certificate, an IPv4 source translation. You'll have an application group, and then it walks you through the rest of it. So it's wizard-like as well, where it kind of gives you step 1, step 2, step 3, until the application is defined. And then you can wrap that up with security zones and security policies to ensure that you are securing the application and defining it for the use case that's desired. All right, we'll hit cancel here. There's some additional settings that are available for you. You can set the domain name, identity certificate, the security zones, the global port pool, security controls you can set as well for those private applications. So you can set intrusion policy, your variable set, and your malware and file policy. Now, maybe we'll finish off with a couple things. We can integrate this with Cisco XDR platform. We can also integrate with what we call as Threat Intelligence Director, the ability to bring in third-party threat intelligence leveraging taxi, URLs, or a straight upload, but the ability to add additional indicators and observations into the platform and certainly take action against those indicators and observations as the policy dictates. We also have backup and restore. Let's go ahead and create a quick schedule here. You can see you can do backup, nmap scan, report, Cisco recommended rules, download latest updates, install latest updates. Maybe that's what we'll do. And maybe we make it recurring and we do it once a week. If there's any updates, send an email if we have a mail relay, and all of a sudden now we have our scheduled install updates that are happening once a week. So in summary, we created a branch policy with multiple different attributes driving towards a very specific outcome to allow for that branch office to have the ability to access the internet. We built a NAT-based policy. We restricted based on a corporate approved Chrome application. We introduced intrusion prevention, malware inspection. We built a health policy, a platform policy to ensure consistent configuration across our branch devices. We checked out remote access VPN, the traditional method of providing access using a wizard-based system. We then checked out zero trust application, the ability to drive towards zero trust outcomes leveraging Cisco Secure Firewall. We introduced software-defined WAN to assess the quality of the interfaces for which the application is leveraging, but we're just scratching the surface. There's so much more. In order to see more, you're going to have to check out the SecOps section of the demo.